Hey friends, I'm River Ranger Emily, and today we're going to talk about the water cycle. So to start it off, if you're at home, pause this video and go grab a glass of ice water. We're going to use it later for a demonstration. Once you've got your water, put it just out of sight so that we can look at it later. Alright, before we start, let's break it down a little. H2O, that's water, right? But what does that stand for? It comes down to the itty-bitty basics, elements. No, not like the Avatar, but like those on the periodic table. The H means hydrogen and the O means oxygen. Water is made up of 2 hydrogens and 1 oxygen, hence the H2O. And when you bring those 3 things together, you get what us scientists call a molecule. So some quick facts about water. Planet Earth is the only planet that we know of that has the water molecule in all 3 states. Think to yourself, do you know what the 3 states are? They're a solid, liquid, and gas. Another cool thing about water is that it is a polar molecule. Now, what on earth does polar mean? Well, the easy way to remember it is that polar means pull. So to help you remember, take your hand and make it into a fist, and then stick out your pointer finger. Your pointer finger in the middle and the center knuckle is going to be your oxygen. And then at the tip and the base where your knuckle is are going to be your 2 hydrogens. Your 2 hydrogens are friends, so they want to be close together, right? So they're going to pull in close to each other, leaving the oxygen at the top pointing up and the 2 hydrogens at the bottom pointing down. So that polarity is these 2 hydrogens pulling together. And now you have a fun fact that you can tell all your friends. Another really cool thing about water is that all the drops of water that are here today always have been. So that means that the water that you're drinking doubled as a dino's bath, or maybe even the queen's tea. But how did all that water get back to you? The water cycle.
Say you have a puddle in your backyard in the morning, but by the end of the day, it's gone. It didn't grow legs and walk away, did it? Nope, it evaporated. Evaporation is the first part of the water cycle that we're going to learn about today. Earlier we talked about how water molecules can exist in different states. Well, evaporation is the change when water goes from a liquid state into a gaseous state. Imagine you and your friends are packed into an auditorium or the gym for an assembly, and the AC isn't working. Hot, right? You'd want some space. Evaporation is when all those little water molecules get so hot and they're shaken so much that the auditorium doors burst open and you and all your water molecule friends scatter out all over the playground, all over the grass, and get some space. That's exactly what's happening in the puddle. It got so hot and crowded in there that the molecules wanted to have their own space. And gas will fill up any container that it's put in. So when it goes into the air, it goes around all the world with our atmosphere acting as the container. To demonstrate evaporation, we are going to use acetone instead of water because it evaporates much faster than water. But remember to never use chemicals without an adult. Even household chemicals aren't toys. So, we're at that puddle we talked about earlier. But how do we get it to go away? We're going to use heat and energy from the sun. We're going to give it a shake to simulate that energy. And you're going to keep shaking and shaking and shaking. After a couple seconds, check it. You can see it's already starting to evaporate a little bit more heat, a little bit more energy, and voila, your puddle has evaporated. But now that the gas is up there, how does it get back down? Well, as you get up high in the sky, it gets cold. So if you and all your friends were really cold, wouldn't you want to bunch together and snuggle up, share your heat? You'd want to pack in tight. Well, that's exactly what water does, and it's called condensation.
Well, as water molecules get colder and colder, they're going to grab more and more of their friends, and as they bundle up all together, that becomes a cloud. Now grab that glass of ice water that we put aside earlier. As you grab it, you'll notice that the outside is wet. That is because all the water molecules in the air are coming in contact with the ice-cold glass, causing them to condense back into a liquid. So everyone is together and shivering from the cold way up in their cloud until bam, they get so close and they get so heavy that they turn back into liquid. They condense. and then they fall from way up in the atmosphere all the way back down to Earth. Now, some drops never quite make it, but instead re-evaporate into the air. But the others that fall down are either in a liquid or in a solid state, depending on how cold it is. And that is what we call precipitation. So, on your warm days, you get rain, and on your coldest ones, you get snow. So, the warmer it is, the more space the molecules need. But the colder it is, the more they want to pack in together.
To demonstrate condensation and precipitation, we're going to use some fake clouds. We've got 2 cotton balls right here, and that acetone that we've been using. So, all these water molecules are going to build up in these clouds, and it's going to soak them up as long as it possibly can. But eventually, they're not going to be able to hold anymore, right? It's going to get so much water in them that it's going to start raining. Just like that. Now, as the liquid falls back down to Earth, it's not just going to stay where it landed, right? Or else it'd be swimming everywhere. This is called runoff and collection. The precipitation runs down all the mountains and the hills and even things like the roof of your house to collect in streams, rivers, oceans, you name it. But it takes some time to get there, and that's called interception. So think about sports. When the other team gets the ball, it's called an interception. So when something other than the river gets the water, it's also called an interception. Trees especially aid in this. Their leaves and their branches slow down the fall of water so the ground has time to absorb it. Interception is key in flood prevention. So after the water has done its own obstacle course, it rolls into the valley and even into the puddle in your own yard.
Now let's do the whole thing. Here's our model of a watershed, or an area of land that water moves through and across in order to reach a final location, like our ocean right here. Now our puddle that evaporated earlier has been condensating way up in the sky. But it's getting pretty full, so it's about time for some precipitation. But as it starts to precipitate on our watershed, it's going to run down our mountains and into the water below. In order to get this evaporated back up, we apply that heat and energy from the sun by giving it some good old shakes. We give it lots of energy. And there you have it. It's evaporated.
So there we have it, friends. Evaporation, condensation, precipitation, and runoff and collection. The water cycle. Thank you for watching. Go tell all your friends all your new scientific knowledge.